Chapter 1 Method 1.2 Mole Concept Part 2 1.2 Mole Concept. At the end of this topic, students should be able to define each of the following concentration measurements. 1. Molarity. 2. Molality. 3. Mole fraction. 4. Percentage by mass. 5. Percentage by volume. Calculate each of the following concentration measurements: molarity, molality, mole fraction, percentage by mass, percentage by volume. But for this calculation, you have to answer and practice the exercise given after you learn about it. Alright, before we go further for calculation of each concentration unit, for each of concentration unit, it must consist of solute. Solute is defined as the substance being dissolved in a solution. Next, solvent. Solvent defined as the substance in which a solute dissolves. Third, solution. Solution defined as a homogeneous mixture composed of one or more solids dissolved in a solvent. I give you the figure to show the differences between solute and solvent. Finally, it mixed together to form solution. Now we recall back what we learned about moles and the formula related to the moles. There are three main parameters to calculate moles. The first one formula is come from number of particles. In order to calculate moles, it must divide with Avogadro constant or vice versa. Next parameter is the moles can calculate it from the mass. So if you have the mass, we can calculate moles which divide with its molar mass and vice versa. And the last main parameters, the moles can calculate it from the volume of gas. If we have to calculate moles from the volume of gas, we must divide by molar volume at its occurred, either at room temperature or STP, standard temperature and pressure. The first unit of concentration is molarity. Molarity has the symbol of capital letter of M and defined as the number of moles of solute dissolved per unit volume of solution. The unit volume used are liter or decimeter cube. Its formula is molarity equal to moles of solute in the unit of mole divided by volume of solution in the unit of liter. And the unit calculation for molarity is mole per liter or mole per decimeter cube. The tips to convert the unit of volume: 1 liter equal to 1 decimeter cube. 1 ml equivalent to 1 centimeter cube. and 1 decimeter cube equivalent to 1000 centimeter cube. Second unit of concentration is molality. Molality has a symbol of small letter of m and defined as the number of moles of solute dissolved per unit kilogram of solvent. It has the formula molality equal to moles of solute in the unit of mole divided by mass of solvent in the unit of kg. The unit for molality is molal or mole per kg. We have to remember mass of solution equal to summation of mass of solute and the mass of solvent, and volume of solution is not equal to the volume of solvent. Next unit is percentage by mass. Has a symbol of percentage W over W, defined as the percentage of the mass of solute per mass of solution. Has a formula percentage weight over weight equal to mass of solute divided by mass of solution multiply with 100. The unit of percentage by mass is percent. For example, if the label has 10% W over W sodium hydroxide, it means that 10 grams of sodium hydroxide NaOH dissolved in 100 grams of solution. 10 grams of sodium hydroxide dissolved in 90 grams of solvent. The solvent here is water. 10% of sodium hydroxide in 100% of solution. Next parameter, percentage by volume. The symbol is percent V over V, defined as the percentage of the volume of solute per volume of solution. Has a formula percentage V over V equal to volume of solute divided by volume of solution multiply with 100, and the unit is percent. To remind, this is the unit that often used to describe the concentration of a solution that was prepared by dissolving a liquid in some solvent. The last unit of concentration is mole fraction. Has a formula as a symbol of X, capital letter of X, defined as mole fraction is the ratio of the number of moles of one component to the number of moles of all components present. The formula is mole fraction. If the species that we have to calculate is the A, so it's XA equal to moles of A and A divided by total moles. Symbol is N total. Whereas Na represented the number of moles of component A in the mixture, while N total represent the total number of moles all components in the mixture. For example, the mixture do not only has A, maybe there are B and so on. So N totals there is summation of Na plus Nb plus etc. The unit of mole fraction is dimensionless, which is no unit.